Okay, so just to refresh your memory, this is one of the two that we had you do at the end of the last lesson. And if you remember, I said when you draw this one, it's 4 plus 6 times 2 plus 2. That negative charge means you add 24 valence electrons. Carbon in the middle, oxygen around all the sides. Everything gets 8. Oxygen in the, or the carbon in the middle also gets 8. And if you draw that, that adds up to 26. So you erase 2 on the middle, and then you can pick any one of those 3 atoms to erase 2 from. So if you erase 2 here, then you would put the double bond in between where you erased it from and put it in brackets. But there's no reason you had to put it on this oxygen. You could have put it down low or on the other side. And that's what's called resonance, when there's more than one option. Okay, if you do the SCN minus, you got 6 plus 4 plus 5 plus 1, because a negative means negative 1, 16. And again, SCN. Choices for this one look like this. That's one of them. The other choice, that's an N, looks like this. And the last choice looks like that. Essentially, you either have 2 double bonds or a triple bond somewhere. And so when you have a situation like that, that is referred to as having resonance, when there's more than one correct way of drawing it. So Lewis structures can help us predict the likelihood of a compound having resonance. Generally speaking, it means it has double bonds. Okay, we're going to talk about one more set of rules, and we're going to talk specifically about carbon. You may have remembered that I said carbon doesn't very often get dots, and it really doesn't. I can only think of one case in which it does. And it does a lot of covalent bonding. There's this whole group of organic compounds, compounds referred to as organic chemistry. And that's where all of your medicine and all of your biology and all of your fuels that are, fossil-based fuels, all of that comes from carbon compounds. And so when you're drawing carbon compounds with Lewis structures, carbon, generally speaking, does not have lone pairs. Okay, I could think of one that it does, but other than that, none. No dots. And carbon will not be on the outside. It will, generally speaking, be on the inside of a molecule if at all possible. So they stick together. So if I was to draw C3H8, okay, I would do the same thing I do with all my Lewis structures. 3 times 4 plus 8 times 1 means I have a total of 20 to work with. And the way this works is carbon, carbon, carbon. They form the interior part, and then you put the H's on the outside, and remember, hydrogen only gets a single bond. And if you add this up, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's done. And so that's the way you draw organic compounds. If I was to do C2H6O, you have a bunch of different choices with this one. Again, 4 times 2 for the carbon, 6 times 1 for the oxygen, and 6, or the hydrogen, and 6 for the oxygen. It's a total of 8 plus 12 is 20 again. And so you have a couple of options. The carbons are in the middle. I would put the oxygen right there. You don't have to. That's one option. And then, again, carbon always gets bonds. And so H, 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 H. I still have one extra H to put on, so I'm going to put it there. Can't put it on the carbons because they only get 4 bonds. And then the oxygen needs 2 more dots. This is actually ethanol. And that's one of the options. It's not the only option, but it is one of the options, and it adds up to 20. So Lewis structures for carbon, carbons go in the center. So now we're going to talk about something called the exceptions to the octet rule. Sometimes certain elements can add extra bonds around themselves because they have a very large radius. So these are things towards the bottom of the periodic table. That's where the radius gets bigger. And these guys can exceed the octet rule. That means go beyond, greater than 8 electrons around them. The rule is, though, any extra electrons, either as a bond, so you might draw an extra line, or as a set of lone pairs, they go on the center atom. They don't go on the edges anywhere. They go on the center atom. So if I was to draw PCl5, I have 5 plus 7 times 5 is a total of 40. P is in the middle, Cl, 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 Cl. That's only 4 of the Cl's. I actually have 5. And the rule is you have to put it on the center atom. So find a corner and stick that Cl in there. So that center atom right now has 10 electrons around it. And phosphorus will frequently do that. Not always. And then give everything else 8. And if you add that up, that adds up to 40. So in this case, you put the extra electrons in the form of a bond on that center atom. Okay, so each one of these guys exceeds the octet rule. So draw the Lewis structures and we'll talk about them. So SCl6, 6 plus 7 times 6 is 48. S is in the middle. Put the Cl's around the outside. And again, it's got 6 chlorines, so I've got to put them on the center atom. So Cl here, Cl there. Give everything 8. Takes a long time. And adds up to 48. Notice there are no double bonds. No doubles or triples on these guys. You do double and triple bonds when you need to have less electrons. Well, these guys I have more. And so Br31 minus 7 times 3 plus 1 is 22. Br, Br, and Br. So Br in the middle. 8 electrons on everything. Well, that adds up to 20, and I need to have 22. So what I'm going to do, go back, is I'm going to kind of erase that a little bit. Oops, I erased the B as well. And I'm going to put the extra electrons as a lone pair on my center atom. Now the XeF4, now you might notice that xenon is not actually on the chart for having an electronegativity, and that's because typically it is very stable, very low energy, and it doesn't want to let its electrons go. But if it's something very electronegative like fluorine, it is possible to get xenon to give up some of its electrons. Its radius is so large that some of those outside electrons are able to be stripped off for the fluorine to share. And so what you have is you have 8 valence electrons for the xenon, and 4 times 7 is a total of 36. Xe in the middle. Now let me erase that. That was not good. This is the problem doing it on the here. I can't just erase it with my fingers like on the board. So Xe, F, 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 and F. Give everything 8. Right now the xenon has 8. So everything's fine. But the way I've drawn it is I have drawn 32. I need to stick 4 extras on, and so you stick those on the xenon. Last one is ICl5, 1 minus. 7 plus 7 times 5 plus 1 equals, let's see, that's 8 plus 35. 35 and 7 is 4. It should not be 1 minus. It's a typo. 42. Can't have odd numbers. So I, Cl, 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 Cl. Got to put the extra Cl on the center atom. Give everything 8. And that adds up to 40. I need to put one more in there, 42. So, how do we know when we need to exceed the octet rule? Generally, draw the Lewis structure with all single bonds, just like before. Give everything 8, just like before. And then if you still have extra electrons that you haven't put them on anything, or you have extra atoms that you need to bond, they always go on the central atom.